Hello everyone. Our project is all about improving Airbnb experience for hosts and guests in Canadian cities. We are exploring Airbnb listings data, verifying property images, predicting prices, and exploring user reviews. Our aim is to figure out what factors drives pricing and higher user ratings. By doing this, we are empowering hosts to adjust their pricing strategies and ensure guests to have a great time while also making sure those property images are genuine. We are not stopping there. Using the World City Center dataset and key college locations, we are investigating whether proximity to these places impacts listing prices or user ratings. Also, by examining user reviews, we are categorizing sentiments and identifying areas that needs most attention as well as highlighting the positive aspects of these listings. Now, to handle all this, we are dealing with some pretty substantial data. We have got listings, reviews data, and property images adding up to around 2 GB. We are using Apache Spark's powerful distributed processing capabilities to make the most out of this data. Let's dive into how we have converted all these data into insights. This is the complete architecture diagram. Initially, we encountered issues in handling CSV data from Airbnb due to commas within the text fields. So we converted CSV files to JSON using a Python script. Then we collected the property images from the Airbnb listings URL, and also we collected the latitude and longitude details of world cities and colleges data. All the raw data is loaded into S3 buckets. Apache Airflow played a crucial role in managing various tasks such as data transformation, spatial analysis, and sentiment analysis. Dedicated DAGs were used to handle EMR cluster creation, steps execution, and termination of cluster on AWS. By enforcing task completion before initiating the next, it ensured a sequential workflow, streamlining task execution and workflow efficiency. S3 was the backbone storage solution for all our datasets. It also played a pivotal role in filtering data, thereby reducing the data load to PySpark code. EMR optimized PySpark operations, implementing parallel and distributed processing of datasets. We have used Amazon QuickSights for presenting the data visually. Then moving on to spatial analysis, we linked Airbnb data with city and colleges info using PySpark, measuring distances accurately. We efficiently joined the two datasets, employed caching and broadcast joins. As a result of this analysis, it seems closeness to city center doesn't much affect prices and reviews. To attract more guests, highlighting other unique features of the listing matters. But being near colleges strongly relates to higher ratings, suggesting it could bring more bookings. Then we did feature importance analysis. Our analysis highlights key features that significantly impact both listing prices and review scores on Airbnb. We have created new columns from the existing features using PySpark. We have implemented random forest regressor to generate the feature importance matrix. For prices, we find that amenities like bathrooms, bedrooms, and positive reviews have a major influence. Similarly, for review scores, we see that factors such as review frequency and host behavior significantly affect guest satisfaction. These insights provide actionable strategies for hosts to improve their offerings, potentially increasing the number of bookings and satisfaction rates on the Airbnb platform.
Further, we are performing sentiment analysis on user reviews to categorize the comments into positive, negative, and neutral sentiments. We started with pre-processing the last 3 months' data using NLTK libraries, which involved detecting the language, removing stop words, fixing abbreviations, eliminating punctuation, numbers, and so on. Post this, using the text blob library, we calculated sentiment scores for each comment. These scores quantify the sentiment of the text, which ranges from -1 to +1. We then categorize these scores into positive, negative, and neutral sentiments based on a predefined threshold. This bar chart represents the categorized data by each city. We can see from the chart that the positive sentiment is predominant across all listed cities. Also, there is a consistent trend where the percentage of negative sentiment is about one fourth of the total. The percentage of neutral sentiment is relatively low across all the cities. To conclude, the differences between the cities are not drastic, indicating a possible overall similarity. To further enhance our sentiment analysis, we did collocation analysis to identify significant word phrases that are strongly associated with each sentiment. We utilized ngrams library to generate bigrams and trigrams to extract word combination from the processed comments. We then analyzed the frequency of these ngrams and aggregated the counts for each listing. To focus on the most significant one, we ranked the n-grams by their frequency and produced the most positive and most negative phrases. This is a word cloud generated based on our analysis for the set of positive data. The most common phrases in the positive trend include beautiful place, super host, house, which indicate that businesses can use this insight to create marketing campaigns that speak directly to customer interest and expectation. And this is a word cloud generated for the set of negative data. Most common phrases in the negative trend include dirty bathroom, disappointed place, and this reveals that the host can use this insight to address recurring issues or concerns effectively. In the next part, we are doing price prediction, making use of feature importance analysis done previously to create a predictive model to predict prices. Some of the important features include the number of bedrooms, property type, and features that we created based on our analysis, like days since last reviewed. Along with this, we have added our sentiment scores, which are aggregated for each listing and joined along with the listing data. For this model, we have chosen the GBT regressor for its ability to handle complex nonlinear relationship between features and its efficiency in processing large data sets. The model is trained on the prepared features, and upon evaluating the model, we got an RMSE of 117 and an R square value of 0.99. This model can be used by Airbnb hosts to fine tune pricing model by aligning rates with customer priorities and sentiment for a better success rate.
Now we are going to demonstrate image URL analysis. Here we have curated the image dataset, ensuring it captures vital details like listing ID, property URL, and property type. One challenge we navigated was the class imbalance. There were about 21 distinct property types with insufficient number of sample URLs. For example, Vancouver City has around 300 images for entire condo, but only 2 images for board property type. To tackle this, we have strategically narrowed our focus to 2 distinct properties, entire condo and houseboat. To scale this dataset for correctly classifying all the 21 properties, we will need more number of URL samples from Airbnb. Using PySpark, we have fetched property image URLs and transformed those URLs into actual images and also organized them into training and testing folders with a ratio of 80:20. Our dataset consists of around 300 images for entire condo and 200 images for houseboat. Each image carries a file size of around 1 MB. Training the model. Here, the model development process makes use of TensorFlow and Keras ML libraries. We have made use of pre-trained ResNet 50 architecture to extract features from property images. We have chosen ResNet 50 for its proven effectiveness in image classification tasks, providing deep feature extraction capabilities. To improve our model's accuracy, we have expanded the model with additional 2 dense layers. We have trained the model for 8 epochs to refine its ability to recognize and classify property images accurately. Evaluating the model. Here we are evaluating the accuracy of predictions by comparing the model's classifications against the true property types, providing insights into its effectiveness. Our model achieved a validation accuracy of 87% and a testing accuracy of 80%. Let's have a look at the confusion matrix. This matrix shows that the model correctly predicted entire condo 54 times and houseboat 17 times. It incorrectly predicted 8 instances of entire condo and 12 instances of houseboat. Now let's have a look at the transformations. Here is the link to our AWS QuickSight dashboard. Now the first chart shows listing count by city. This shows that Toronto constitutes to around 40% of Airbnb listings, significantly driving user revenue, while Quebec City's 5% suggests untapped potential for business expansion. Now the next chart shows listing categories by city. Here we are classifying listings into categories such as bachelor friendly, kids or family friendly, and wheelchair accessible
by employing predefined keyword lists associated with distinct features. This infers that Airbnbs should increase the number of listings which are bachelor friendly in cities like Quebec and Winnipeg to attract more student population. Now the third chart here shows average price by city. The average price by city indicates that Vancouver has the most expensive Airbnb properties with an average price of $216, while Winnipeg has the least expensive one. The next chart shows most popular property types by city. Here, entire rental unit and entire condo are the most popular property types across all the cities in Canada. Now let's come to next chart. It shows profile completeness status of host, which is categorized by property type. This chart shows the profile completeness status of host from each city based on details like host profile picture, host ID, and other details. It shows that entire rental unit contributes to around 38% of the property types. The last chart here shows host responsiveness by city. This one calculates host response time into three categories such as highly responsive, least responsive, and the host who typically responds within end of day. Winnipeg showcases an 88.5% rate of quick responders, while Toronto has 2.4% of hosts taking more than a day to reply. With all this analysis, we aim to empower Airbnb business to make data driven decisions. Thank you for your time.